Hi students, this is Mr. Yao. Today we're going to talk about 4.12, where we will review everything we learned from 4.9 to 4.11, all about these three different forms of quadratic functions and how to graph them. First, when we want to graph a quadratic function, we always find a vertex first, no matter what kind of format we have. Then we find another 3 or 4 points, depend on the form we are given. Here's a look at all the three different forms: standard form, intercept form, and vertex form. Standard form, f of x equals ax squared plus bx plus c. We always find the vertex first, and the vertex comes from negative b over 2a. After we have that, we're going to plug it in to find the y-coordinate. The other point we always look for in standard form is the y-intercept. When you plug in 0, we're just looking at this last number, the plus c, that will give us the y-intercept, which is 0, c. Next, we learn about intercept form. For intercept form, we can easily identify the x-intercepts. It's always the opposite number of whatever is given inside the parentheses, so it's p0 and q0. As for the vertex, p plus q over 2, because the vertex is right in between the x-intercepts. It's on the axis of symmetry. So after we find the x-coordinate for the vertex, we are going to plug it in so that we have the y-coordinate. Lastly, we learned vertex form, a times x minus h then squared plus k. So for the vertex form, we start with the vertex. Since it's a minus h, we're going to have the opposite, which is h, and then comma k. With graphs, we also talk about the connection between the discriminant and how the graph may look. We can use the discriminant to decide how many x-intercepts we may have. The discriminant is b squared minus 4ac. When it is bigger than 0, we have 2 distinct x-intercepts. When it's equal to 0, we have 1 x-intercept, and when it's less than 0, we have no x-intercept. Now let's look at a few examples to review these. Number 1, we're going to decide how many x-intercepts we have first, and then we're going to graph. So we're going to calculate our discriminant. b squared minus 4ac in this case is negative 6 squared minus 4 times 2 times negative 4. So we have 36. Careful with the signs, that's minus minus, so become plus. And we have plus 4 times 4, 16 times 2, 32, which is 68. And it's bigger than 0, so we have 2 x-intercepts. Next, we are going to graph. Since it is in standard form, we're going to find the vertex first. Negative b over 2a, that's going to be negative 6 on the top over 2 times 2. That is going to give us 3 over 2. Then we're going to plug in 3 over 2, which is 2 times 3 halves squared minus 6 times 3 halves, and minus 4. After simplifying, that's going to be 9 over 2 minus 9 minus 4. This is 9 over 2 minus 13, which gives us negative 17 over 2. So my vertex is going to be 3 halves and negative 17 over 2. Next, I'm going to put that point down as 3 halves, so it's around right there. Then it's going down to there. We have a point right there. A different color. After we have that, we can actually find our y-intercept. F of 0 is going to be negative 4, just this number on the end. That's my y-intercept. I have 0, comma, negative 4, which is right there. And by reflecting, I can find my other point there. Lastly, I just need to plug in another point. I can choose to plug in either negative 1 or 2 or 4, any of them. So I'm going to just plug in a f of negative 1. That's going to be 2 times negative 1 squared minus 6 times negative 1 and minus 4, which is 2 plus 6, which is 8, minus 4, which is 4. So I have negative 1. That is going to give me another point, which is going to be right there by reflection. Now I can connect all my points. Then I have my parabola right there. That's example 1. Example 2, we're going to identify our intercepts. First is going to be the opposite of the numbers given, so it's 2, 0, and negative 3, 0, right there. Next, I'm going to do my vertex. Well, before we do that, I forgot. I need to find how many x-intercepts I may have. B squared minus 4ac. That means I actually need to change into a standard form. I'm going to multiply everything open. F of x, if I multiply everything open, is going to be negative 3x plus 6 times x plus 3. And then I'm going to distribute. That's going to give me negative 3x squared. After simplifying, that's plus 6x. And then it's minus 9x, so minus 3x, then plus 18. In order for me to decide how many x-intercepts I may have, b squared minus 4ac. I would have negative 3 squared minus 4 times negative 3 times 18. That's going to be 9 plus 12 times 18. That is going to be 216, which is 225, which is greater than 0. So I have 2 x-intercepts. Another thing is you don't even have to use the discriminant. By the statement, we already know the x-intercepts are 2, 0 and negative 3, 0. So you have 2 x-intercepts already. It's pretty clear. Okay, so we already found our x-intercepts. Next, find the vertex. I'm going to do the 2 plus negative 3 all over 2, which is negative 1/2. Now I'm going to plug it in. F of negative 1/2 is negative 3 times negative 1/2 minus 2, negative 1/2 plus 3. That's going to be negative 3 times, that's negative 5 over 2 times 5 over 2. So I have 4 on the bottom, 5 times 5, 25 times 3, 75 on the top. That's kind of an odd number, so just try to be as close as you can. 2, 0 right there, negative 3, 0 right there. Then we have negative 1/2 in the middle, and 75 over 4, which is actually way off the graph, like way on the bottom. So I'm just going to kind of pick a point. When you actually do a question on the quiz, you won't have anything like this. But that is actually going to be close to like negative 20. So it's way, way, way down there. And I still need another point. I'm just going to do, say, f of 0. Plug it in. I have negative 3 times 0 minus 2, 0 plus 3. And that is going to be negative 3 times negative 2, so 6 times 3, which is 18. So my graph looks like when a 0 is going to be 18, which is going to be actually way above, not quite below, way above. And I have another point like there, and my graph will look something like that, which is way off the graph. But when you're actually doing a question like this, you're going to be provided with the right graph. That's example 2. Next, example 3. We're going to find the zeros and the vertex and decide if it's a maximum point or a minimum point. So first, we're going to find the zeros. That means we need to set it to 0 and solve. So f of x equals negative 3x squared plus 6x plus 24 equals 0. Now I'm going to factor out the negative 3. I have x squared minus 2x minus 8 equals 0. And I can factor. I will get minus 4, x plus 2 equals 0. My intercept would be right there, 4, 0, and negative 2, 0. These are my zeros. Next, my vertex. My vertex, negative b over 2a. I can actually use my intercept form as well, or I can just use the standard form to begin with. Negative b over 2a is negative 6 over 2 times negative 3. I will have a 1. F of 1 is negative 3 times 1 squared plus 6 times 1 plus 24. That is going to B. 30 minus 3, so 27. My vertex is 1, 27. Then I can decide if it's a maximum or minimum. My A is a -3. It's less than 0. That means my graph is going to be opening down, so I have a maximum. Next, example 4, same idea. That means I need to start factoring first. This time it has a leading coefficient, so I'm going to use the cross method. -20 and then 3. After you write them down, you kind of can see you can't exactly factor it. That means we can't even use that. We have to use the quadratic formula for this one. So it's -b, -3, plus minus square root of b squared, which is b squared minus 4ac. I'm just going to calculate on the top. B squared is 3 squared minus 4 times -5. That is going to be 9, then plus 16 times 5 is 80, so I got 89. 89 in there. On the bottom, 2 times 4, which is 8. So it's -3 plus minus square root of 89 all over 8. These are my x. So I have my zeros, which is -3 plus square root of 89 all over 8, comma 0, and -3 plus, not plus anymore, just did a plus, so now it has to be minus square root of 89 all over 8, comma 0. These are my zeros. I can find my vertex. My vertex, and do -b over 2a, which is -3 all over 8. Plug it in, f of -3 all over 8. 4 times -3 all over 8 squared plus 3 times -3 all over 8 minus 5. That's going to give me 9 over 16 minus 9 over 8 minus 5. So I got -9 over 16 minus 5, which actually is -89 over 16. My vertex is -3 over 8, -89 over 16. My A is a 4, which is bigger than 0, so I have a minimum. Okay, that is example 4. Next, we talked about all these 3 different forms and how to actually convert among them. So standard form to intercept form, we are going to factor. From intercept form to standard form, we're going to distribute and simplify. Same thing with vertex form to standard form, distribute and simplify. From standard form to vertex form, we're going to find the vertex by finding the -b over 2a. And if we want to do intercept form to vertex form, we're going to find that p plus q all over 2 and then plug it in. And we have the function right there. As for vertex form to intercept form, well, we're going to need to change into standard form first, and then we're going to factor. Now let's have a look at a couple examples. Example 5. Changing from that to vertex form, -b over 2a to find the vertex, -3 on the top, 2 times 6 on the bottom, so we have 1 over 4. I'm going to plug in f of 1/4. That's going to be 6 times 1/4 squared minus 3 times 1/4 plus 2. And that is going to give me 3 over 8 minus 3 over 4 plus 2. So it's -3/8 plus 2, which is 13 over 8. So my vertex is 1/4, 13 over 8. My A is 6, so my vertex form is f of x equals 6 times x, opposite, so minus 1/4 squared, and plus 13 over 8. Example 6. Now we're going to write that as vertex form. First, we're going to find the intercept, so 1, 0, and -8, 0. 1 plus -8 all over 2, which is -7 over 2. Plug it in. F of -7 over 2 is -2 times -7 over 2 minus 1 times -7 over 2 plus 8. That is going to be -2 times -9 over 2 times 9 over 2. So we got 81 over 2. My vertex is -7/2, 81 over 2. My A is the -2, so my vertex form looks like -2 in the front, then x, that's a -7/2, so add, which means the opposite, and then add 81 over 2 on the end. That is example 6. Lastly, we also talked about how do we write the functions when we are given some points or a graph. Let's start with example 7. We're given vertex form, so I can start with vertex form. F of x equals a, I don't know the a because I need to use the other point to solve for a, x plus 4 squared minus 5. Now I'm going to put in the other point, f of -5 halves equals a -5 halves plus 4 squared minus 5. So I got 8 times, that's 3 halves squared minus 5, which is 9/4 a minus 5, which is 13. So I can get 9/4a equals 18. Get rid of the 9/4 from both sides. My a should actually be 8. Final answer, f of x. Well, not quite final answer. The vertex form is f of x equals 8 times x plus 4 squared minus 5. Lastly, we do need to change that into standard form. So that is going to be 8 times x plus 4, x plus 4 minus 5, which is 8x plus 32 times x plus 4 and minus 5. And if I open all the parentheses, f of x is going to be 8x squared. That's plus 32x and plus another 32x, so plus 64x. And 4 times 32, that's 128, minus 5, 123. That is my final answer. Last example, example 8. We can see the vertex right there. We have 2, 0, and we have -6, 0. So I can start with my vertex form, which is f of x equals a times x plus 6 and x minus 2. As for another point, I have a couple of options. I can use a vertex, which is -2, then 8. I can also use the y-intercept, which is 0, 6. In this case, I'm going to use the 0, 6. So f of 0 is a times 0 plus 6, 0 minus 2, which is -12a, which is 6. I mean, my a is going to be -1/2. So I have f of x equals -1/2 times x plus 6 times x minus 2. I'm going to distribute the -1/2 in, so -1/2 x minus 3 times x minus 2. I'm going to open all the parentheses to multiply everything. I'm going to get -1/2 x squared minus 3x plus 1/2 x times -1/2 x times -2 is a plus x at the end plus 6. So my final answer, f of x equals -1/2 x minus 2x plus 6. That is everything for 4.12 review. Thank you.